The next one we will do is a flowchart for the software of the digital protective relay. So those digital relays are working because they are integrated with this is the computer system, similar to the one power computer system. So they have to follow the standard software procedure. Those are similar to the computer hardware. You can drive the computer without a software. So you want to apply the computer, you have to program with the software. Similarly, this relay need to be programmed. So that now I will use as a relays are typical relays are operations are programs are flowchart. So normally we start from here, start. The stepwise, the first thing that we have to relay have to acquire the input data. Input data will be from the line data are transferred by the transducer and such as the eliminated low pass only they allow. So this is we call the data input. Data input for the digital. This is we call the digital data input. Digital data input. Okay, then we have to pass it through the filter. Filter means elimination of the low frequency and the higher harmonic component. So then we have to pass it through the filter. So eliminate such and higher harmonic. So we have to eliminate the sub and the higher harmonic, and then this one is can go to the operation. So this is really we operate. The operation should be in a sequence. Sequence really in the power line. So this is the relays are relay 1, relay 2, and relay 3 like this. And 4 happen here. Relay 2 operate fast. This one operates the second. This is operates the start. So this one this is the generator. So this is we call as a operation of the crystal. So this is a sequence. Sequence means determination of crystal. So crystal determination, and then they go to the output. Output means this output trade instruction. Output trade instruction. Then go to stop. So this is a typical algorithm, flowchart for the relay operation program. So normally we acquire the data. Data is taken from the line through the transducer, and then the feeder. We feed out the starch and the low pass, high harmonic pass. Then we operation sequence means that we determine the result. When we allocate the relay here, in this case 4 current from here to here. Relay 3 is a fast the 4 issue operate fast, and then relay 2 and relay 1 operate. So then output trade instruction is a trade as output circuit breaker and the stop. So this is the flowchart for the digital protective relay. Okay, the next one will be the digital relay and the 16-bit. So there may be that in the power system they are many relay circuit here. More than the one, we use one computer. Normally we use one computer control the sublet relay operation. The whole system operation is being controlled by the control terminal. Control terminal is one computer. It's one is attached to the SCADA software, and then we also use a PLC or like this. So those are computer program, and then the all relays are controlled by the central computer. Now I will draw this centralized system. So firstly, we got the transducer unit. So for example, we consider the system 8-bit relay here. So this is the 8 line. This is we call it transducer. So this is we call the auxiliary transducer unit. Okay, the transducer unit we connected. So this is connected to the line of the control function. Then those are connected with the fader. So this is fader we connected. So we are connected with the filter. Okay, this one filter connected, and then those relays are the many lines. So all the line transducers are connected to each filter, and then we don't need to look at all the data on the die. We have to use a sample and hold circuit. SHB sample hold circuit. So we use a sample hold circuit. So this becomes SH. So this is sample hold circuit. Okay, sample hold circuit. We take the sample all the data, and then we put to the multiplexer. So this one we put to the multiplexer. Put to MBA. This is the multiplexer. Multiplexer means there are many lines, but you got the only one computer. So those are data coming from the server line, and those are combined at the one data here, and then we use this as our multiplexer. And this one is now connected to, up to this is the analog data, so you have to convert to the AD. AD means the analog to digital converter. So AD, you have done all the digital electronics. This is the AD means the analog to digital converter. So this one becomes a digital. So analog equalizer function, digital only 1 and a 0 function. So digital. So those digital function, we put the input data buffer. IDB is input data buffer. The reason to do the input data buffer is your digital circuit is that tools are sensitive. Too sensitive for the power system, they are very expensive. So you cannot allow the electrical current to pass through. When the current passes through, because of the sometimes the surge or the harmonic happen or the abnormal surge happen, your computer electronic circuit will go. So because of this, we have to put the buffer. Buffer means we can use it as photoelectricity or like this. So the current is transferred to the light energy. So by this way, we can make that such as protected. So we have to use the input data buffer. So this digital signal and the data buffer are operated by the clock. Clock means in the computer you see the clock. Because this one you open the computer every date and time you can record. All the functions are harmonized by the clock. So these clocks are they have instructions as a multiplexer. What time is to take the data, what time cut off the data, like this, or what time change the data from the analog signal, what time input data buffer is to active. So these are the controlled by the clock. Okay, those clocks are after that this one is coming out. This one go to the data bus bar. In the computer, you can see the ribbon cable, so those are the data bus bar. You see the motherboard is connected to your hard drive connected to the output circuit. So those are the data bus bar. You can see the ribbon cable. So those data bus bar are being controlled by the central processing unit CPU. So this is CPU with the central processing unit. So then this are connected to memory, also connected to the data input, DI. DI means the digital data input. So data input is utilized. Sometimes you need to use by the manually program the manual. Normally this one automatically set the transfer, and also sometimes you need to insert the program. So in the industrial control systems, there are more than one program to utilize. In the CNC machining, there are several programs. The late machining, if you cut this pinion, there one program. If you drilling, boring, another program. So the other program, similarly the relay, they are a different program. So the programmer, the operator can enter the different program, or they can take out the different program, edit and the RAM. So because of this one, we also need to utilize the data input. Data input will be the keyboard on the mouse like this, and the industrial system that can be the another transducer and the sensor. We can put like this, and then this data input here, they also go to the data output. So this is the 0 minute data output. So this output data connected to protected relay. So this is the DA converter and the relay. DA means digital to analog converter. DA means digital to analog converter. Because as the data the signal coming out from the computers are the digital one. So if you want to drive the relay circuit breaker, in this case, the digital need to be converted to the analog. So this is the converter and the protective relay is offering. So this is a typical overview diagram of the 8-bit protective system, control system, including the digital relay. Data output, also we can connect it to the relay or the transformer test setting. So another data output get connected to the DA converter and the transformer test setting. Transformer test setting means that sometimes in the system voltage too high, in this case it can automatically drive the voltage regulator. So voltage regulator automatically being drive, and then we adjust that setting. So we can regulate the voltage. So under this thing, I talk about the digital relay. So we can utilize digital signal. Those digital signals are controlled by the main computer, and this one that drive the output relay. So together with this digital one, now we can utilize the telecom system. The very early type relays all the relays are placed near the power line. So that this relays are pilot wire connected to the current transformer. Current transformer send the signal to the relay. So relay treat the circuit breaker via wire relay. So instead of that, we are now using the wire relay. Today we allocate the all relay in the main power station, and all the trip signal is sent by the transducer, and this signal are sent from the line side to the station through the telecommunication network. It can be the telephone line, broadband like this. So those signals are received by the receiver, and this receiver process the signal, they transfer to the digital, and the digital relay they operate, and this send the control signal to the circuit breaker through the telecommunication line. So this is the line diagram here. So this is the line. Line got this circuit breaker. So this is a CB. And here we use this current transformer we allocate. Or we can also locate the potential transformer CD, PD we allocate and we put to the transducer. So this transducer then they connected to transmitter. So the signals are transmitted by the carrier frequency. So signal transmission to carrier frequency. So you can use an oscillator. This oscillator signal transmission, you want to transmit the signal from here to here. In this case, you have to combine with the oscillator. Oscillator produces a carrier frequency, so put the two control signal with the carrier waveform and send. So those signals are then you receive by the receiver. Receiver, and we also use a demodulator. Demodulator means that in your radio set, the demodulator means the signal is converted to the telecom signal is converted to the electrical signal. So this is a demodulator, similar to the modem, the computer. So this demodulators take out the signal here, and then here you also got the fader and the surge protection. This is the analog to digital converter like this. Simple whole circuit. This one is go to the simple whole circuit and connected to the analog to digital converter and a multiplexer. Then go to the computer. Okay, this computer, then we can put the output signal connected to the digital to analog converter. Digital to analog converter and go to the transmitter. So this one analog to converter go to modulator. Modulator means we combine the signal with the carrier frequency. In this case we have to utilize the oscillator. So this signal, the control signal coming out. So this control signal sent to the circuit breaker. So this signal sent to circuit breaker. So this is a trip circuit. So this one here, this circuit also got the receiver. This trip circuit trip the circuit breaker. So this signal is sent to here. So this is a typical control system by using the protective relay. So firstly CDPD, they send the signal and transfer to the transducer. So this signal are transmitted. So in this case, carrier frequency combined with the carrier frequency, the receiver receive and demodulate, and fader surge protections are the perform, sample whole circuit, analog digital, and then they feed to the computer. And after the computers process signals are converted to the analog and modulator combined with the carrier frequency that produced by the oscillator, then control signal sent to the relay side and circuit breaker it receives and trip circuit operate and circuit breaker we off. So this is the typical system. So that because of this one in the system, very large system, we use as a central coordinated control. So this is a very large power system. We use a central coordination control as a connected to the area control. Area control like this. So this area control, they also got a local control. So local control is AC, so we can use the AC, here also AC, AC, and the AC. And then network substations are located at the bottom. So they will be the bottom, will be the network and substation. So this is a very large system. But in here with them will be only the local control and the network or the area control. Very large power system network. In this case we use like this.